Hey, it's Mr. Lum again, and today we're going to be looking at calculating and finding out what the empirical formula is. So first off, what is an empirical formula? An empirical formula is the most basic formula. So I have an example right here, and it is C3H6. So what we would say is that C3H6 is the real formula. This is, there are 3 carbons and there are 6 hydrogens. So that is the real formula, or in other words, that is what we would call the molecular formula. But the empirical formula just essentially means the ratio of carbons to hydrogens, or whatever other atoms that are in the compound. So the empirical formula is essentially telling you what is the ratio of what type of atoms are present. So the empirical formula is saying there is 1 carbon and for every 2 hydrogens that are there. Okay, so that's what the empirical formula is. So the empirical formula, so we have an example right here of N2O4. This is the, this is the molecular formula right here of N2O4, and we want to find out what is the empirical formula of that. So what it means is, what is the ratio of nitrogen to oxygen? And we can find, like, there's a common number that we can kind of move out of here, so we can divide both sides by 2, and we can say there is 1 nitrogen for every 2 oxygens. And so this NO2 would be the empirical formula. Okay? So, but that won't be quite as easy on some of these other questions. So imagine we have a question that says this: a sample is made up of 43.7% phosphorus and 56.3% oxygen. And it is saying, what is the empirical formula? Well, phosphorus has a different mass than oxygen, and so we're going to have to do a little bit of math on this to figure out what is the empirical formula. So I have 4 steps right here, and the first step says just change the percentages right into grams. So I'm going to write my phosphorus, and I have my oxygen right here. And so my first step, it says change the percentages straight into grams. So instead of writing 43.7% and 56.3%, I'm just going to change those into grams. Okay. And now we're going to do, we're going to change these into moles. And so if we look up the molar mass for phosphorus, it's 31.0. And the molar mass for oxygen is 16.0. So if we did this calculation, we would change the phosphorus into moles and the oxygen into moles. Now we're going to find the ratio between the phosphorus and the oxygen. So first, we're going to calculate these things and have our moles of there. So I'm going to go 43.7 divided by 31, and I get 1.4096, and that's moles. And then I do the same thing for here, 56.3 divided by 16, and I get 3.51875. I'm just going to round this to 9 moles right there. Okay, so now I want to find what is my ratio. And how I have to find my ratio is, the easiest way is just divide by the smallest number. So I'm going to go between 1.4 and 3.5. 1.4 is my smallest number. So I'm going to go 1.4096 divided by 1.4096. And that's nice and easy. That's just 1. And then I'm going to go 3.519 divided by 1.4096, and 1.4096, and I get 2.5. I get 2.496 right there. Okay. Now, my last step right there, it says multiply in order to get a whole number, or what we consider close enough. Okay, so right here I have 2.496. It's not quite a whole number, but it's about 2.5, and that's not a whole number. So we're going to pretend that's roughly 2.5. And if I times that by everything by 2, what I get is 1 times 2 is just a 2. And 2.5, essentially this is 2.5 times 2 is 5. Okay? So what that means is for phosphorus, there is 2 phosphoruses, and for oxygens, there's 5 oxygens. So I'm going to write that now. Phosphorus, there's 2, and oxygens, there's 5. So this is our empirical formula, is P2O5. It might be our molecular formula as well, but it is it just means for every 2 phosphoruses there are 5 oxygens. So the molecular formula might be something like P4O10, something like that, but we don't know that. This is just the empirical formula right now. Later on we'll learn about how to figure out the molecular formula. Okay, but that's how we find out our empirical formula. Okay, so we have same type of question. It says, what is the empirical formula of carbon, hydrogen, nitrogen, and here are the percentages that make up everything. So same thing, I write my stuff, carbon, hydrogen, and nitrogen. My percentages, 50.5, 5.26, and 44.2. I change it into grams. I then change it into moles. Do the easy one first. And then the ones where I have to actually use a calculator, 50.5 divided by 12 equals 4.208. And then 44.2 divided by 14, 3.157. Divide by the smallest number. So my smallest number is the nitrogen. And then calculate that. So I'm going to go 4.208 divided by 3.157, and I get 1.33. 5.26 divided by 3.157, and I get 1.66. 1.666 or 1.67. Okay. Now, at this point right here, this is where some of your mathematical intuition needs to be. If you see something that is ending in a 0.5, like a 1.5 or 1.49, which is really darn close to 1.5, then you're going to be multiplying it by 2 2 to get to a whole number. If you see something ending with a, say it was 3.25, okay, 25 is the same as like a quarter, you're going to have to be multiplying everything by 4 in order to get to a whole number. If you see something ending with a 3.3 or a 6.6 or a 6.7, somewhere right there, 0.33 is the same as a third. 0.66 is the same as like 2/3. And so how to get to a whole number is you're going to have to be multiplying it by a 3. So I'm going to do that right here. I have to multiply this by a 3. Okay. So I just ran out of room right there. So you kind of have to be able to recognize some of those numbers after the decimal place right there. So when I take 1.33 times 3, we get roughly about 4. You have to round to the whole a whole number right here. So you get like 3.99, which is about 4. Okay. And so when you take 1.67 times 3, you get roughly about 5. And then 1 times 3 is just 3. So what is our final answer? Well, we have carbon. There's 4 carbons. And for every 4 carbons, there are 5 hydrogens. And there are 3 nitrogens. And this is our empirical formula. Our molecular formula might be bigger than that, but it would follow a 4 to 5 to 3 ratio. But we'll figure out how to solve molecular formula later. But this is our empirical formula, and that's how we solve it.